Hello guys, welcome to Mathematics Academy for Africa, an organization whose main objective is to promote the study of mathematics in schools and universities. If you are meeting me for the first time, I am Ken Elson, an engineering student as well as a mathematics and further mathematics teacher at St. Benedict Catholic Bilingual College in Yaoundé. So in this video, before I tell you what we are going to be looking at, I would like to draw your attention to some key things before we begin. First of all, if you are watching this video, maybe it might appear blur in your device. Some people usually complain in the comment section. So please, you always have to adjust your YouTube resolution power to 360 or above. Okay, so if you don't know how to do that, you can just search for a video on YouTube on how to adjust the YouTube resolution power. Is going to help you, and when you adjust your YouTube resolution power, you'll be able to see the video clearer. Secondly, I beg on you guys to like the video as you're watching, comment along the way, subscribe to the channel if you have not yet subscribed, and share the video after watching the video. I plead on you, share the video with your friends. It's going to go a long way to help them, especially those who are preparing for the advanced level. If you're a teacher and you're watching the video, please, I plead on you to share the video with your students and also tell them to share the video with their friends. I want to give special gratitude to all my fans, those who have been there from the beginning, supporting me, liking, commenting, sharing, and subscribing. May God bless you all. Before we go, if you want to join our WhatsApp groups and you're in the advanced level, you can get to me on WhatsApp via this number on your screen, 676597498, with your name, your school, and the subjects you are offering, so that it's going to ease my work. Basically, I am going to send you the WhatsApp links to the respective groups of your subjects, okay, and you are going to join. So endeavor to get to me on WhatsApp. If you are in advanced level and you have difficulties, you can join our WhatsApp revision groups. We have WhatsApp revision groups daily. It can help you. If you have your questions, you can ask there and you always be responded to. And finally, before we go, I want to tell you guys that we have a website. The name of our website is www.estudyuniverse.com. We are going to be uploading past GC questions and their solutions, as well as some videos on our website. So endeavor to visit our website very soon. Okay, you can visit it now, but the content is not yet available. But this is just to tell you that something is coming up. So from time to time, I'm going to be relaying the informations in the WhatsApp groups concerning if content is available on the website already or not. So endeavor to visit the website from time to time to check if the content is already available there. So like I said, the name of the website, or the the link to the website, is www.estudyuniverse.com. Finally, before we begin this video, I have produced a further mathematics revision guide. I call it the simplified series. It's almost like a textbook because it's about 350 pages. So here is the cover page of the book. If you're interested, you can get to me for more information on WhatsApp. That is my number displayed on the screen. Alright guys, so let's get started in this video. Endeavor to like the video, like I said, comment, subscribe, and share the video with your friends. Okay, so in this video we are going to be looking at the correction of the second sequence evaluation that was written by the lower seed science student of St. Benedict Catholic Bilingual College in Yaoundé. So I was actually the setter of this exam, okay, and this exam was made up of two sections. Section A was multiple choice and section B was structural. The duration was 2 hours and the students were expected to answer all the questions. So in this video we are going to be solving section A only. In the next video we are going to solve section B. So endeavor to turn on your notifications once you have subscribed to this channel, so that when other videos are going to be uploaded, you'll be notified to come and watch. Okay, so let's get started with the first section. Okay, so like I said, we have two sections, and in this video we are going to be doing only section A. At the end of the video, I'm going to give you highlights of section B so that you can maybe solve and send me your answers on WhatsApp for me to correct. So section A, we have this section is made up of 10 questions, and each question is followed by 4 suggested answers. Only one answer is correct. By justifying, choose the letter corresponding to the right answer. Every question is allocated for 2 points. Okay, so basically what we are going to be doing is that I am going to display the question to you, and I give you a brief analysis of the question as well as its solution, and we tick the right answer. So let's begin with question number 1. Question number 1 is basically on elementary number theory, and the question reads: it is known that 4 to the power 2n plus 1 is congruent to 4 mod 10, and 5 to the power n is congruent to 5 mod 10 for any n in the set of integers. What is the unit digit of 4 raised to the power 2024 plus 5 raised to the power 2025? So first of all, before we begin, I'm going to drill you on what the unit digit of a number is. Basically, the unit digit of a number is simply the remainder when that number is divided by 10. Okay, that's the basic definition of the unit digit of a number. I'm saying it because I'm saying mod 10, and 4 mod 10 is simply the remainder when 4 is divided by 10. 5 mod 10 is a remainder when 5 is divided by 10. So that's basically modulo arithmetic. So for example, 22 divided by 10 is equal to 2 remainder 2. So the unit digit of 22 is 2. Think about tens and unit. Okay, so you can clearly know what unit digit is. Let's take 30 for example. 30 divided by 10 is 3 remainder 0. That is why the unit digit of 30 is simply 0. So from this we can initialize on the fact that the unit digit of a number is the remainder when that number is divided by 10. Now if I am adding two numbers, for example 22 plus 30, it gives me 52, and the unit digit is 2. So basically the unit digit of a sum of the sum of two numbers is the sum of their unit digit. You see, if I add 2 to 0, I'm going to get 2. So the unit digit of 22 plus 30 is simply the sum of the unit digits of 22 and the unit digit of 30, which is giving us 2 plus 0, which is equal to 2. In fact, 22 plus 30 is 52, and the unit digit of 52 is 2. So here we are going to use the fact that 4 mod 10 is a remainder when 4 is divided by 10, and 5 mod 10 is a remainder when 5 is divided by 10. So the unit digit is the remainder when when the number is divided by 10. So let us begin by evaluating the unit digit of 4 raised to the power 2024 using the fact that 4 raised to the power 2n plus 1 is congruent to 4 mod 10. So using the fact that 4 raised to the power 2n plus 1 is congruent to 4 mod 10, we clearly see that for us to have 2024 is an even number. Okay, 2n plus 1 is an odd number. So it therefore means that if I take 4 to any odd number and I divide by 10, the remainder is 4. This is what this congruence equation means. It means 4 raised to the power any odd number divided by 10, the remainder is 4. But since 2024 is an even number, I am going to multiply both sides of this equation by 4 so that I get a general relationship of the unit digit of 4 raised to the power any even number. So if I multiply both sides by 4, here I'm going to have 4 raised to the power 2n plus 1, since they have the same base, I add their powers, I'm going to get 4 raised to the power 2n plus 2. When I multiply 4 with 4, I get 16, and 16 mod 10 is the remainder when 16 is divided by 10, and that remainder is 6. But from the properties of congruencies, 6 is congruent to 6 mod 10. So it means that 4 raised to the power 2n plus 2 will be congruent to 6 mod 10. Okay, now from there we clearly see that if we can write 2024 in the form 2n plus 2, then the unit digit of 4 raised to the power that 2024 is simply 6. because the unit digit is a remainder when that number is divided by 10. It is clear that 2024 is 2 times 1011 plus 2. It therefore means that 4 raised to the power 2 times 1011 plus 2 will be congruent to 6 mod 10, because our n here is an integer. 1011 is an integer. So if we can write 2024 in that form, it means that the unit digit of 4 raised to the power 2024 is simply 6. Or we can say 4 raised to the power 2024 is congruent to 6 mod 10. We are done with finding the unit digit of 4 raised to the power 2024. Now what about the unit digit of 5 raised to the power 2025? We use the knowledge that 5 raised to the power any integer, when divided by 10, it leaves a remainder of 5. So that is a unit digit. Okay, in fact, 5 raised to the power any number will always end in 5. So the unit digit of 5 raised to the power any number is 5. So we can conclude that 5 raised to the power 2025 is congruent to 5 mod 10. Now we want to find the unit digit of the sum of the two numbers. So if we add the two equations from the properties of addition of congruencies, from the addition property of congruencies, we simply have, if we add the left hand side, we also have to add the right hand side. So this plus this will be congruent to 6 plus 5 mod 10, because we are in the same mode. Okay, so 4 raised to the power 2024 plus 5 raised to the power 2025 will be congruent to 6 plus 5 in mod 10. 6 plus 5 is 11. But what is 11 mod 10? 11 mod 10 is a remainder when 11 is divided by 10, and that remainder is 1. Okay, and from the properties of congruencies, every number is congruent to itself in another mode. So 1 is congruent to 1 mod 10. But clearly we need the unit digit of this sum, and we said that the unit digit of a number is the remainder when that number is divided by 10. So we clearly see that 4 raised to the power 2024 plus 5 raised to the power 2025 is congruent to 1 mod 10, and 1 is the remainder when this number is divided by 10, hence its unit digit. So we can draw a conclusion that the unit digit of this sum is equal to 1. So the answer is option D. Do well to comment if you have a difficulty in understanding these concepts. Elementary number theory is not a topic to play around with. It is sometimes complicated to understand. So do well to drop your comments in the comment section. I'm always going to be there to reply to your comments so that you understand easily. So let's go to the next question. Okay, so moving on to question 2, I'm going to display the question and we perform the brief analysis, and I provide the solution and we get the answer, and we move on to the next question. So question 2 says that which of the following statements is false? A, if P divides Q, then the GCD of P and Q is equal to P. B, there exists a unique K in the set of integers such that 12 factorial is equal to 13k minus 1. C, if 3x is congruent to 1 mod 7, then x is equal to 5 plus 7t, where t is an integer. And D, if a is an integer and p is prime, then a to the power p minus 1 is congruent to 1 mod p. This is still elementary number theory. So this question is asking us to pick out the statement which is false, and the statement which is false is our correct answer. So let us begin by analyzing every statement. Let us begin with the first statement. It says that if P divides Q, then the GCD of P and Q is equal to P. This statement is perfectly correct. For example, 2 divides 4 clearly, so the GCD of 2 and 4 is 2. Remember, GCD is the greatest common divisor. So once a number divides another, the GCD of the two numbers is a smaller number. When we say an integer a divides another integer b, we mean that the integer b is a multiple of the integer a. In fact, the integer b can be expressed as the integer a times another integer k. So 2 divides 4 because 4 is equal to 2 times 2. You see, there exists an integer such that 4 is equal to 2 times that integer, and that integer is clearly 2. So the greatest common divisor of two integers is equal to one of the integers, provided one of the integers divides the other. So the first statement is perfectly true. Let us go to the next statement. The next statement is telling us that there exists a unique value of a certain integer k such that 12 factorial is equal to 13k minus 1. So I would like to bring us to the notion of the Wilson's theorem, which says that if p is a prime number, then p will always divide p minus 1 all factorial plus 1. That is the theorem. We don't necessarily need to know how to prove it. Okay, so the theorem says that if p is a prime number, then p will always divide p minus 1 all that factorial plus 1. Now if you see 12 factorial, we think of 13 because 13 is a prime number, and to get 12 factorial we are taking 13 minus 1. So if we take our p to be equal to 13, 13 is a prime number because it has only two positive divisors, 1 and 13, or it has 4 divisors in total, plus or minus 1 and plus or minus 13. So since 13 is a prime number, it means that according to the Wilson's theorem, 13 will divide 12 factorial plus 1. In fact, 13 will divide 13 minus 1 all factorial plus 1. But 13 minus 1 is 12, then factorial plus 1. So it means that 13 will divide 12 factorial plus 1. So we say that, like I said, if a divides b, it means that b is equal to a times k. So if 13 divides 12 factorial plus 1, it means that there exists a certain integer k such that 12 factorial plus 1 is equal to 13 times k. Okay, from here we simply have 12 factorial is equal to 13k minus 1. And we see that this k is a unique value. There are no two values of k. There will be only one value of k that will satisfy this equation. So option B is correct. Now let us move on to option C and analyze. Now in option C, we just need to solve this linear congruence equation in one unknown and see if we can get the general solution, and we convert that general solution to a linear equation. So the way x is congruent to 1 mod 7, solving for x here, we are simply finding what we call the modular inverse of 3 in mod 7. Okay, so to get the value of x here, we just need to multiply both sides of this congruence equation by the inverse of 3 in mod 7. The inverse of 3 in mod 7 is a number that when you multiply that number by 3 and you divide by 7, the remainder is 1. It's clearly 5 because 5 times 3 is 15. 15 divided by 7 leaves a remainder of 1. We now replace 3 bar with 5. We multiply with 1. You simply have 5. So x is equal to 5 mod 7. If you convert 5 mod 7 into an equation, that if you convert x is congruent to 5 mod 7 into an equation, we simply need to take 5, which is a remainder, plus 7 times a certain constant. No time to explain that, but this is how we convert. We just take 5 plus 7t, where t is an integer. So we clearly see that option C is also correct. It therefore means that the wrong option is option D. But why is option D wrong? Let us read option D. Option D says that if a is an integer and p is a prime number, then a to the power p minus 1 is congruent to 1 mod p. That is what it says. I'm going to take your knowledge back to the Fermat's little theorem, or the Fermat's theorem. This clearly is the statement for the Fermat's theorem, but a certain sentence is lacking. The Fermat's theorem says that if a is an integer and p is a prime number not divisible by a. Sorry, let's take it the other way around. Let us say if p is a prime number and a is an integer not divisible by p. Okay, it means that your a should be an integer and your p should be a prime number, but your a being an integer, it should not be divisible by p. For example, maybe we can take 5 is a prime number, okay, and 25 is an integer, but the Fermat's little theorem will not work in this case because 25 is divisible by 5. Okay, so because of the fact that this option did not talk about the divisibility of A by P, then the option is wrong. So option D is wrong, and that is our correct answer, since the aim of the question is to get the statement that is false. Like I said, elementary number theory is not a topic to joke around with. If you face difficulties in any explanation, do well to comment in the comment section. I'm going to get to you. Let us move on to the next question. Alright, question number 3. It reads, in 3x congruent to 2 mod 5, the sum of the biggest negative and the smallest positive solution is. So we need to solve this linear congruence in one unknown, and we get the value of x. Then we further get the biggest negative solution alongside the smallest positive solution, and we add them together. So 3x is congruent to 2 mod 5. We need to multiply both sides of this by the multiplicative inverse of 3 in mod 5. The multiplicative inverse of 3 in mod 5 is simply a number that when you multiply that number by 3 and you divide by 5, the remainder is 1. That number is 2, because 3 times 2 is 6, and 6 divided by 5 leaves a remainder of 1. It therefore means that I just need to replace 3 inverse here with 2. When you multiply this 2 and the original 2 in the congruence equation, you get 4. If you convert it to an equation, we have x to a linear equation, we have x is equal to 4 plus 5 lambda, where lambda is an integer. If we try to list out some values of x, maybe we can begin with when lambda is equal to -2 or maybe -3, depending on what you want, but there are infinite values of x since lambda is a parameter. Okay, so we can maybe start with lambda equal to -2. We are going to have x to be equal to, remember that this 3 dots means that there are so many values in front before we are taking -2. So maybe we could also take -3, okay, but I actually listed a set beginning from -2 and ending at 2. So and ending at 1 even. So when lambda is -2, our x is 4 minus 10, which is -6. When lambda is -1, our x is 4 minus 5, which is -1. When lambda is 0, our x is equal to 4. When lambda is 1, our x is equal to 9, and so on and so forth. Now, what is the biggest negative solution? Is -1, because we clearly see that the negative solutions begins from -1, -6, and it proceeds, but the biggest negative solution is -1. Now the positive solutions begin from 4 to 9 and so on and so forth, and the smallest positive solution is 4. So the sum of the biggest negative and the smallest positive solution is simply -1 plus 4, which is equal to 3. So option D is correct. Alright, so we are left with 6 questions aside this question. So question 4 reads, consider the statements P and Q given. You have P is a statement x squared minus 4 is greater than 0, and Q is a statement the absolute value of x is greater than 2. Which of the following is correct? We have A, we have B, we have C, and we have D. So we are done with elementary number theory. The first 3 questions was actually based on elementary number theory. Now we are moving to logic. Okay, so we need to relate these 2 statements, but look at the analysis we are going to do. So we begin with x squared minus 4 is greater than 0. If I add 4 on both sides, I'm going to have x squared. So x squared minus 4 is greater than 0 if and only if x squared is greater than 4. It's very logical. If and only if the square root of x squared is greater than the square root of 4. But the square root of x squared is the absolute value of x, that's a definition, and the square root of 4 is positive 2. Please, the square root of 4 is not plus or minus 2, but it is only positive 2. Okay, so the square root of a number is always positive. So the square root of x squared is the absolute value of x, which is always positive, since no matter the value of x, the absolute value is always positive. So it is clear that the square root of 4 cannot be plus or minus 2. It will only give you positive 2. Let me throw more light on the square root function. Now, basically a function is a mapping that whenever you input some elements, you get results. Okay, now it is a one-to-one mapping, or it is either a one-to-one. It means that if you can input an element, okay, and you bring out maybe you bring out one and only one image. That's what I'm saying. Or you can input several elements and those elements produces one image. We have no problem with that. But when you input an element into a function and the result gives you two different values, that is not a function. Again, you are abusing the definition of a function. So basically a function is a one-to-one or a many-to-one. So the square root function is a function. So you cannot tell me that the square root of 4 is plus or minus 2. Telling me that the square root of 4 is plus or minus 2, it means that you are telling me that the square root is not a function, because you realize that if you replace 4 into the square root and you're telling me that the output is plus or minus 2, it means it is now a one-to-many, which is false. That is not a function again. So sorry for delaying, but I had to throw more light on that because many students always get confused. So the square root of x squared is the absolute value of x, and the square root of 4 is positive 2. So you clearly see that x squared minus 4 is greater than 0 if and only if the absolute value of x is greater than 2. Here's our conclusion. Okay, one of the statements is P and the other is Q. So the final statement is P if and only if Q. Option Z is correct. Let us move on to the next question. Okay, so question number 5, it reads, it's still on logic. Which of the following is a contrapositive of a conditional statement? I will be happy if I pass this test. A, I will not pass this test if I am happy. And the responses go down to D. Okay, so first of all, I want us to let P and Q be which statements. The first statement is P, I pass this test, and the next statement is Q, I will be happy. The given statement which says that I will be happy if I pass this test is simply the conditional statement P implies Q. Remember that the statement P implies Q is read as if P then Q. So you clearly see that the statement after if is your hypothesis, which is P. That is why my P is I pass this test. Okay, so my P is basically I pass this test, so it begins the sentence, and then my Q is the conclusion. So if I pass this test, since the statement I pass this test is a statement immediately after if, that is our hypothesis. So me calling that statement to be P, it means that this conditional statement is P implies Q. Now the contrapositive of a conditional statement P implies Q is simply gotten by negating the statements and interchanging their positions. So when we negate the statements, we call it the inverse. When we exchange their positions, we call it the converse. So the contrapositive of a conditional statement is simply the converse of the inverse. Inverse means negate the position, negate the statements and allow them in their positions. Converse means interchange their positions. So when we negate and we allow them where they are, we just have not P implies not Q, and then when we exchange, we now have not Q implies not P. So basically the contrapositive of a conditional statement is the converse of the inverse. Now what is the statement not Q? Not Q is I will be angry. Okay, that is I will not be happy or I will be angry. What about not P? Not P is I fail this test or I will fail this test. Okay, so we can now write that contrapositive as either if I am angry, then I will not pass this test or I will fail this test, or we can say I will be angry if I fail this test. So I want to write it so that you clearly see me putting the if after. So if I am angry is the statement not Q. Then the statement coming after is a conclusion, which is not P, and P is I pass this test. So this not P will I will not pass this test, which is I will fail this test. So if you look clearly, the correct option is D, which reads if I am angry, then I will not pass this test. All right, so we are moving on to question 6. This is already 30 minutes. Guys, please watch till the end. It's very important. Question 6 reads, using the substitution u equal to x minus 4, find the partial fraction resolution of x plus 4 divided by x minus 4, all that raised to the power 8. So we have changed the topic of the day. We are now with partial fraction resolution, applying the knowledge of substitution. So if our x is equal to, if our u is equal to x minus 4, it means our x is equal to u plus 4. So the partial fraction x plus 4 divided, the single fraction x plus 4 divided by x minus 4 to the power 8 becomes, our x here is u plus 4, but we need to add 4 again, so we have u plus 8. Then x minus 4 is u, we now raise it to the power 8, we have u to the power 8. Now basically these two terms in the numerator have a common denominator, so we can separate into the single fractions or into the partial fractions, and then we sum. So we have u divided by u to the power 8 plus 8 divided by u to the power 8. The u divided by u to the power 8, if we apply indices, we get 1 divided by u to the power 7. This other portion remains unchanged. But what is u? Our u is x minus 4. So it therefore means that x plus 4 divided by x minus 4 raised to the power 8 is equal to 1 divided by x minus 4 raised to the power 7 plus 8 divided by x minus 4 raised to the power 8. So the correct option is option D. Alright, so we are with question number 7. It reads, using the fact that 2 divided by 4r squared minus 1 is identical equal to 1 divided by 4r minus 1, 1 divided by 2r minus 1 minus 1 divided by 2r plus 1. What is the sum from r equal to 1 to n of 2 divided by 4r squared minus 1 in terms of n? So here we are basically using our knowledge of partial fraction, and the partial fraction of this single fraction has already been given to us. So we go along, we just go directly in applying the knowledge. Okay, so we have that 2 on 4r squared minus 1 is identically equal to 1 divided by 2r minus 1 minus 1 divided by 2r plus 1. So we can sum both sides from r equal to 1 to n. Summing the left hand side, it means we need to sum the right hand side. Now let us replace some terms and we see what is basically happening with this sum. We call this sum a telescopic sum, and this method is what we call the method of differences. So when we replace r to be 1, this term here becomes 1 divided by 2 into 1 minus 1, which is 1. This term becomes 1 divided by 3. Plus, when r is 2, this term becomes 1/3, this term becomes 1 on 5, and so on and so forth, till when r is equal to n, this term becomes 1 divided by 2n minus 1, and this term is 1 divided by 2n plus 1. Now you clearly see that negative 1/3 will cancel with positive 1/3. Okay, negative 1/5 will definitely cancel with, if we continue writing, remember that this is r equal to 1, r equal to 2. If r is 3, this term here will become 1 on 5, which is positive. You cancel with this negative. So definitely there will be a term which is negative that we cancel with 1 divided by 2n minus 1. So we are just going to be left with the first term, which is 1, and the last term, which is negative 1 divided by 2n plus 1. Those are the only two terms that are not going to cancel. So if we simplify, we are going to get that this sum is identically equal to 2n divided by 2n plus 1 if we find the LCM and simplify the numerator. So there we go again, option D is correct. Okay, we are in question number 8. 2 more questions to go. Question 8 reads, is taking us back to elementary number theory. Which of the following congruence equations does not have solutions? We have the 4 equations given to us. So I'm going to iterate on some certain facts. Firstly, there exists an integer solution to this congruence equation. Ax is congruent to c mod b if and only if your b here divides ax minus c. So that is a condition for you to have congruence, for you to have integer solutions. Okay, now there is we cannot really relate this condition with this, so we are going to develop something. Now b divides ax minus c means that ax minus c is a multiple of b. We saw that here previously. So ax minus c is a multiple of b. We can subtract b and add c on both sides, and we get ax minus by is equal to c, where y is an integer. Now we know that this is a linear Diophantine equation, okay, and for this linear Diophantine equation to have integer solutions x and y, then the greatest common divisor of a and b must divide c. Okay, so the GCD of a and b should divide c. So in general, we are saying that for us to have integer solutions in this linear congruence, the GCD of a and b should divide c. Okay, so now we are now seeing what we can do. Okay, like when we're here, we never had any clue, but writing as a linear Diophantine equation and knowing that for a linear Diophantine equation to have solutions, this should happen. It means that for this linear congruence to have solutions, integer solutions to be precise, then the greatest common divisor of a and b should divide c. C is a remainder when ax is divided by b. Okay, now from there, if we check, we can now do the checking. The GCD of 2 and 12 is 2 because 2 divides 12. Okay, the greatest common divisor of 2 and 12 is 2, and 2 divides 4 clearly. What about 3 and 7? The greatest common divisor of 3 and 7 is 1 because 3 and 7 are called relatively prime, or they are co-primes, and 1 divides all integers. What about the GCD of 7 and 8? The GCD of 7 and 8 is 1, and 1 divides 7. But check out the GCD of 5 and 10. The GCD of 5 and 10 is equal to 5 because 5 divides 10. So like we said, whenever I have two numbers and one divides the other, the GCD is smaller one. So the GCD of 5 and 10 is equal to 5, okay? And 5 does not divide 4, okay, because our C is 4. 5 does not divide 4 because 5 and 4 are co-prime. It therefore means that there are no integer solutions to option D. Okay, so the last but not the least question number 9, it reads: the LCM of 1386 and 825 and the GCD are respectively. We have the options. So basically we have to do prime factorization, and we apply the formula to get the LCM, that's the least common multiple, and the GCD, the greatest common divisor of those two numbers. So prime factorization is basically expressing every integer as a product of its prime factors. This theorem that says that any integer can be expressed as a product of its prime factors is what we call the fundamental theorem of arithmetic. So we are going to begin with 1386. 1386 expressed as a product of its prime factors in exactly one way. We have 2 times 3 squared times 7 times 11. Those are the various prime factors of this number. Okay, here is it. What about 825? We have 3 times 5 squared times 11. Now, in order to find the LCM and the GCD, we need to make sure that all the prime factors in the first number are in the second number. We realize that in the second number here, there is no 2, so we need to introduce a 2 raised to the power 0, which is 1. Okay, there is no 7, so we also need to introduce a 7 raised to the power 0. Now in the first number there is no 5, so we need to introduce a 5 raised to the power 0. Now the LCM of the two numbers is simply, we take the common prime factors and we raise it to the maximum of the two powers. If we begin with the first prime factor, which is 2, the power of 2 here is 1 and the power of 2 here is 0, so we need to take 1 because we are finding LCM. When we are going to be taking GCD, we are going to be taking the minimum. Okay, so the power of 2 is 1, the power of 2 is 0. In LCM, when we take 2, we need to raise it to the maximum of those two numbers, and the maximum of 0 and 1 is 1 because 1 is bigger. Let's go to 3. 3 here, the power is 2 and the power is 1. We need to take 2 because 2 is the maximum. Let's go to 5. The power is 0 and the power is 2. We need to take 2. What about 7? The power is 1 and the power is 0. We need to take 1. What about 11? They have the same power, so we just write 11. If we multiply, we are going to get 34,650. So this is the least common multiple of the two numbers. Let's go to the greatest common divisor. If we take 2, for example, we are going to take the minimum. Okay, so we take 2. When we take the minimum, it will be 2 raised to the power 0, which is 1. When we go to 3, we take the minimum, it will be 3 raised to the power 1, because you have 3 squared and 3 raised to the power 1. The minimum of 1 and 2 is 1, so we take 3 raised to the power 1. Let's go to 5. We take the minimum is 0 and 5 raised to the power 0 is 1. That's why you see those terms are not written here. Let's go to 7. We have the minimum is 0 and 7 raised to the power 0 is 1. And finally, we go to 11, 1 and 1. So we just have 11. So when we multiply, we get 33. So the greatest common divisor of the two numbers is 33, and the least common multiple is 34,650. So there we go again. Option D is correct. So basically, I set this exam to ease my marking. I just put all the answers as D. Okay, but basically, even if a student does 1, 2, and 3 and realizes that is D, read the instructions. Justify. By justifying, choose the letter corresponding to the right answer. By justifying, so you must justify. So writing option D with no justification, you have no mark as well. So option D is correct. And finally, let us move on to question 10, which I'll basically not solve. Is your assignment to do. But I'm just going to give you the answer. We know that the answer is D, but what is the question saying? Question 10 is saying that if the Diophantine equation mx plus ny is equal to c has a solution, then is D clearly. We have seen it previously. The GCD of m and n should divide c. So D is saying that the GCD of m and n is equal to a, and a divides c. That is why it is correct. So option D is correct. If you can solve and send me your solution on WhatsApp. You can comment in the comment section if you have a difficulty in proving that for a linear Diophantine equation to possess solutions, the GCD of m and n should divide c. I'm going to respond to you. Before we go, I'm going to give you the highlights of what we are going to be seeing in the next video solution for this particular paper. Okay guys, so this is section B, the structural questions. This section is made up of 3 structural questions. You are required to answer all the questions, showing clearly your workings at each stage in an orderly manner. Put all final results in a box. So this is just the first question. Under section B, we have 2 other questions which I'm going to display when I'm going to be solving section B in full. So thank you guys for watching. Do well to subscribe to the channel, like the video, share the video with your friends. Comments. Okay, comments. Your comments are very important. They are going to tell me, they are going to motivate me. Yes, they serve as a source of motivation for me to do more videos, because I'm happy if you are being helped by the channel. Okay, so do well to also help your friends by sharing the video links to them so that they can also visit. And this channel is going to be rated, is going to be favorable in the YouTube algorithm. So thank you guys for watching and stay blessed. See you in the next video.